Coach Jay, how we doing? This is Algebra 3 missing. I am missing on Friday. I apologize for that. I miss y'all a lot, but I am pumped up about the weekend and hope you are too. We do have some stuff to get to today with Algebra 3 and some things that I just wanted to touch base on with you on. So remember the homework 5.2a is due Sunday at midnight. I have pulled off questions on this podcast that you can check out. They're actually the exact questions that are off of that Pearson My Math Lab. So check this out. This podcast will be very helpful for you. My goal is not to waste your time, but just to kind of go through some of these problems with you to make sure that we're all clear on what's expected. So you have that to do on Sunday night. You also have 5.2b, which is due on Monday at midnight. If you are to do 5.2a, do that again by Sunday at midnight. But if you are to get 5.2b done, I'll even say if you get that submitted online, that one is a hard copy. It should be at the front of the room, at the front there. If you get 5.2a and 5.2b done, let's say if you get that submitted before Sunday, I will give you bonus points on that section 5.2b. Okay, so we'll give you some bonus points there. So that's a good incentive to kind of get something rolling going forward. All right. So make sure again today is a good day to be productive. This podcast is completely for y'all and your use there. Try not to waste your time. So we'll go through a couple of those together, and then afterwards, if you have any questions, we could look at some maybe a little bit on Monday too before we go any further with any of the other sections. All right. All right, so without further ado, let's get this show on the road. One thing that I did want to mention to you in starting is this. You'll see the formulas here. You got those down in class. If you remember, we did a couple of these, right? If you saw some of these problems, I think we remember doing in class a little bit, right? I think we did that one in class. I don't know if we quite did that one. We're going to look at one that's similar to that today. I know we did that one in class, or one similar to that. But today what I'd like to do is kind of look at these 5 problems. These are all off your MML. They may be a little bit different, but the whole idea is completely the same, all right? So we're going to go back and forth. I am going to use both the whiteboard to my left as well as, or whiteboard behind me, I'm sorry, as well as the board that's on here as well. So we're going to be going back and forth on there. So let's do this first one up here, okay? All right, let's see if we can get this on here. Perfect. Okay, so first one I want to look at is sine of 225, okay? Sine of 225. Remember that in class we talked about how sine of 225, we're not able to use the unit circle to find 225 degrees. So because of that, we use what's called the sum and difference formula. And remember the sum and difference formula is we say that are there 2 angles that when added or subtracted together gets me to 225. And we know that the 2 angles need to be on the unit circle because that's what we're going to use to simplify, all right? So we're going to see here. We know that 2 angles, and again, this could be multiple different things here, but I think about it and I say, okay, if I have 180 and I added 45 to that, I would get to 225. So we're gonna replace that. We're gonna say, okay, 180 plus 45, and that's what we're gonna put in for our inside of our sine there. So then below sine of 180 plus 45, we're gonna write out the formula. And remember the one that we just had looked at, sine of a plus b, right? And sometimes we use a, b. It doesn't matter. The first one, right? We're gonna say it's a now. We'll say that is gonna be sine of a cosine of b plus cosine a sine b. You might say, Coach, where did I get that from? You will have your formula sheet. You'll be able to use that right there whenever you want to on the homeworks, quizzes, or tests, all right? So now I'm going to make it a little bit bigger so we can see it. A is going to be 180, so we're going to say sine of 180, cosine of b, cosine of 45. I'm just plugging in. Plus cosine of a is 180. And b is 45, sine of 45, okay? And so what I've done right here is I put this all the way on that outside there, okay? Then I'm going to look at sine of 180, and I'm going to say, okay, what is sine of 180? Can I find sine of 180? And I think I can. As I look at that, I remember that, well, yeah, sine of 180 was actually the y at 180 is, if you think about it, I think it's going to end up being 0, right? Because if you think about it, the point is at -1, 0, and the sign relates to y. So the 0 here would be my sine of 180. What's cosine of 45? Well, we know that that's the x at 45 degrees. That's square root of 2 over 2. Cosine of 180, that should be to the left. I think that's -1 there. And sine of 45 is square root of 2 over 2. If you don't have your unit circle, I would take one out throughout this unit so that it would make it a lot easier and a lot quicker for you. So then we know that 0 times anything is 0. We'll throw that out. And then -1 times square root of 2 over 2, that's negative square root of 2 over 2, okay? And 0 minus square root of 2 over 2, we know it's just going to end up being negative square root of 2 over 2, okay? And as I look at this, sine of 225, I think, yeah, I think that, don't we? I think we do. I mean, if you went to your unit circle at sine at 225 degrees, if you were to look down there, you could use this, right? But if you think about it, sine of 225, wouldn't that end up being negative square root of 2 over 2 on your unit circle? So just to show you that they do kind of coincide there, you could, again, use this. You could also know that 225 is on my unit circle, so you could actually use that without doing sum and difference. But I wanted to make sure that you kind of tied that in together on that, okay? So with that being said, we're going to kind of go back into this one here. All right, if you look over here on this value, this is the second one. This second one here is cosine of pi over 4 minus pi over 6. One thing to remember is that if I have two angles that are subtracted, this is going to be cosine of A minus B as the formula. So this will be cosine of A, cosine of B plus, okay, that's going to be plus sine of A, sine of B, okay? So what is A? A is pi over 4. I told you you could put it into radians, and you absolutely could. It actually might be easier if you just left this in terms of radians, just because, I mean, you have that on your unit circle. Really, it's when this is in radians where it's trying to figure out what two angles add or subtract to get to that. And so that's, I mean, again, that's kind of what I would use. But either one of those would be fine. We'll just use this one just for sake of argument here, and we'll go. Okay, so I'm just plugging in pi over 6 in for B and pi over 4 in for A. So now I'm going to look on my unit circle and I say, okay, what is cosine of pi over 4? And I know that that's going to be square root of 2 over 2. I look at where's cosine of pi over 6, that's at 30 degrees. That's going to end up being square root of 3 over 2. Remember, cosines with x, sines with y. Sine of pi over 4, that's going to be square root of 2 over 2. And sine of pi over 6 would end up being 1/2. So then, once I get to here, we're going to distribute across. So we're going to say these two, let me get this right, there we go. These two multiplied, right? Top and bottom. So this right up here would be square root of 6 over 4. I'll put this down here. And this is going to be square root of 2 over 4 on the second one. And I can't add these two because they're not common. So all we would put, this is how we'd put it on there. And this is how I'd put it on my Pearson. I would say square root of 6 plus square root of 2 all over 4. And that's how I would put that answer that's there. Now, what happens if, and I think this right up here got kind of thrown off. Oh, there it is. It's right here. Let's look at one where it kind of goes a little bit different. Let's look at these two. This one is, if you look at it, cosine of A, cosine B plus sine A, sine B. Well, if I remember cosine A, cosine B plus sine A, sine B, I remember that, again, that's a little different, but cosine A, cosine B plus sine A, sine B, right? And these can be representative as A and B or alpha, beta. I mean, again, it doesn't matter the symbols, the first and the second. We know that that formula is equal to cosine of A minus B. So if I know that, this actually becomes pretty simple, because now I can just say, oh, this is cosine of A minus B, where A is going to be the first value, 97, and B is going to be the second value, 67. And so what I can do is I can say that there. Now, when it says, what is the value of this? This is that alpha, right? That'll be 97. That's the first one. And then the beta is the second, which is 67. So you'll plug 67 here, 97 in here. And then it'll ask you this. What is the expression of this? Well, simplified, 97 minus 67 is cosine of 30. You'll notice, too, that this is we're going backwards from what we did up here, right? Here we expanded out, got to here. Over here, I was given this part, and I want you to get back to here or here. So then I say, what is cosine of 30? Cosine of 30 is square root of 3 over 2, and that would be my answer for that specific value there. Look down here. This one's a little different. This one, again, I'm given the formula, tangent of A minus tangent B, right? All over 1 minus tangent A, tangent B. I know that this, based on my formula, is equal to tangent of A plus B, or alpha plus beta, right? Depending, doesn't matter, first plus second. The first value is 25, right? Okay, we got that there. The second value is B, which is 5. So then we're going to say, what is tangent of 25 plus 5? That'd be like tangent of 30, right? Now, you could use your shortcut if you maybe forgot your shortcut or something like that. We know it's y over x, right? And if I did y over x, I would have the y would be 1/2 over square root of 3 over 2. And so that's where I'm going to flip this to the top. And again, if you know your shortcut, you should be good. Cancel the 2's to where I get 1 over square root of 3. And multiply top and bottom by square root of 3 over 3. Square root of 3 over square root of 3, sorry, to get square root of 3 over 3. Okay? And again, this is just simplifying if I did y over x. If you remember that tangent at 30 degrees is square root of 3 over 3, that's sufficient as well. Look over here, you'll get another one very similar, except this time we have tangent of A plus B again, okay? All over 1 minus tangent A, tangent B. The only difference between this one and this one is that this one over here is going to be A is 2 pi over 5, right? This is a little tougher. And the B is 7 pi over 20. Again, like I said, tough. A little tougher here. So once I add, I can't, like angles, this is easy, right? Cosine of 30 degrees over here, 25 plus 5, that's easy. 30 degrees again with tangent. Here we got to get a common denominator, right? When I add. So again, if I'm ever adding fractions like this, I need to get this to where it's 20, right? Because this is 20. So how do I get it to 20? I'm going to multiply top and bottom by 4. And when I do that, I get 8 pi over 20 plus 7 pi over 20. Okay. And when I add those two together, remember when I add fractions together, we keep the denominator the same. And we'll keep, we'll add 8 plus 7 to get 15 pi over 20, which when reduced, if I divided by 5, would be reduced to 3 pi over 4. Okay, 3 pi over 4 when I divide it by 5. So then I find, what is tangent of 3 pi over 4? Well, when I do y over x, you should get something like -1. Okay. Again, that was a lot of problems, and I know that was pretty in depth there. I know we had gone through a lot of this stuff already, so which is good news. The fact that we had already done a lot of this. But I just want to make sure we at least began the process of, continue the process of what we had discussed on block day, and at least give a little bit of a 15, 20-minute podcast to hopefully help you out headed into the weekend. Hey, if you do have some extra questions, maybe if it's on MML, please email me this weekend. If you still have questions, again, just try the best you can, do the best you can on that MML. The hard copy will have questions answered at the beginning of class on Monday. Again, but if you get both in by before Sunday, then we'll give you some extra points there. Hey, great job. Thank you so much for being diligent today and watching this podcast. I hope you have a fantastic day. Have a great weekend. Go Spartans. See ya. Bye.